Anything you can think of, you'll be able to solve using Newton's method. But let me explain the method first. So, and how we'd get to it. So here's a function. It's a continuous function. It has an x-intercept, and I want to determine this x-intercept. I'm going to zoom in tremendously. So this is 1, and this is 2. I can determine for a continuous function, changing its sign, I can determine with the IVT, the intermediate value theorem. I can always find a 1-unit interval in which I show that there is a solution, right? So the function value at 1 is negative, the function value at 2 is positive. It's a continuous function. You cannot jump, right? It goes smoothly. It has to cross here. So I'm going to call this R. This is the root. I don't want to put it here. That's the point where the function crosses the x-axis. So this is our f of x. So here's what Newton came up with. He said this: pick the initial value, to start with. And I can pick either 1 or 2. There are some restrictions. I'll explain what can happen if you don't pick the correct and what are the downfalls. So there are 2 possibilities in 2 situations in which we have to be very careful. So let's say I pick x0 to be 2, the initial value. Okay. Imagine that I draw a vertical line through 2. It meets in this point. And at this point, I will draw the tangent line at that point to the graph of the function, extending the tangent to cross the x-axis. So obviously at this point has coordinates 2, comma f of 2. We know that right here. Now, this tangent crosses the x-axis at a point that I will call x1, comma 0. It's unknown, but definitely since it's on the x-axis, the y value has to be 0. There is no 2 ways about it, right? I don't know this, but what I can say right up front is that x1 is a better approximation of the root of this, of r. So let me just point to it, r. R is the root that I'm trying to find. Would you agree? Yes, I hope you agree, because 2 is here. The root that I'm trying to determine is here. So obviously x1 is a better approximation of the root than 2 was. Now, I have 2 points for this line, right? So I can write the slope of that line as x2 minus x1, y2 minus y1 over x2 minus x1. So I will write f of 2 minus 0 over 2 minus x1. Now allow me, because I like to continue, not to use 2, but use x0. So this is my x0. So this point is x naught or x0, comma 0. You'll see why. I started with 2, so you understand what I'm trying to do, but I would like to write the slope as f of x0 minus, in this case 0, of course, over 2 minus x1. We've had this in the past. There is another way of determining the slope of this line. Can anyone refresh our memory? So we have 2 points, we determine the slope. Oh, of course. So this is x0. So f of x0 minus 0 over x0 minus x1. So can anyone give us the slope of this line in any other way? And I will write it here.
What's the derivative? This is f prime of
x0.
x0.
Awesome. Yes, indeed. Okay. So I have an equation. This I picked. This I have. This is 0. This I picked. So I have. This I can determine. What do you think is the unknown here that I want to solve for? What is the only unknown here? Anyone? What do you think? This I picked, I can plug in the function. This I picked, I can determine the derivative, and I plugged in x0, or 2 in our example. What is the only variable in this equation?
x1.
Of course, that's what I'm looking for. I'm trying to get closer and closer, closer and closer to r. Exactly. So I'm going to solve for r cross multiplying first. So f of x0 equals, there is nothing here, x0 minus x1 times f prime of x0. I will distribute f of x0 equals x0 f prime of x0 minus x1 f prime of x0. I imagine I'm solving just for this. I will move this term and move that term. It's all algebra. And I'll get x1. So move this term here, x1 f prime of x0, and move this term here, x0 f prime of x0 minus f of x0. Okay, obviously I have to divide by this, term by term. So x1 equals x0 minus f of x0 over f prime of x0. Okay, so I'm happy. I determined x1. Okay, so moving on, come back to the graph. Look what I'm going to do next. I will repeat the steps. I will draw a vertical line. It crosses at this point. I will draw the tangent. It will cross the x-axis at this point. And of course, what do you think I'm going to call this point? What is the name of this point that is even closer to R than this one was, and obviously than this one was? Can anyone give us the coordinates of this point? Wild guess.
x2.
Comma.
0.
That's it. Now, what do you think x2 is? A better approximation of R than x1 was. And then I continue, go up, go another tangent, and determine another one, x3 comma 0. And continue the process till I'm happy with my approximation over and over and over. So then, can anyone give us a wild guess? After we perform the same steps and the same calculations, what will x2 equal to? Give it a shot. It's okay if you're wrong. Look at what we have here and just give it a shot.
It's 1 minus f.
Thank you very much, of course. Can anyone give us x sub 3? The third iteration. First iteration. Second. Third. Can anyone give us x sub 3?
x2 minus f of x2 over f prime of x2.
That's it. Two potential problems here. Is this: make sure that you do not pick an initial value that makes this 0. That would be terrible. You're not going to be able to do anything. You're not going to be able to get x1 because this will be undefined. So make sure that this is this case, and make sure you do not pick x0 in such a way that there is a max or min between x0 and r. So what you pick, make sure there is no max min between x0 and r, because it will go in circle and it will not converge. Method in these cases will not converge to R, to what we are trying to find. Okay, so I'm going to pick an example and we'll work on it. And this is the end of the material for test 3.
When we work through this example, do you mind labeling the steps for us? Like, first you do this, second you do this, third.
You don't have to do any of those steps. I was explaining the method, so I'm just not giving simply the formula. You don't have to do any of those steps. Okay, so I would like to look at 27. You'll see in a moment. If after we complete the first problem, we have more questions, then we will discuss any steps. E to x squared. No human being can solve this problem by hand. Okay? So there is no such thing. So in order to solve such an equation, the first step is I have to create a function, right? So solving this equation or solving this equation is the same thing. If I move one of the terms to the other side, it doesn't matter. I'm solving this or I'm solving this is the same thing. But I need the function, and this is my function. Not a nice function. But if I pick something that we can solve algebraically, then what's the point in discussing Newton's method? So I had to pick a situation that no one can solve by hand, because otherwise there is no point in discussing Newton's method. Okay. Of course, in step 2, I have to find the derivative, which is, again, not very friendly. So 2 the square root of 4 minus x cubed with negative 3x squared. And this is even uglier, I would say, e to x squared times 2x. So it's a mess. In other words, in step 3, I have to find an interval. It has to be a 1-unit interval, something like 1, 2, 2, 3, negative 3, negative 2 unit interval. Do not pick something like 0 to 10. No, that's not acceptable. I have to find an interval where the function, and we'll discuss if it's continuous or not, and where, right? So where the function is continuous. Find an interval where f of x is continuous and changes sign by IVT, right? IVT. Not the mean value theorem, the intermediate value theorem. Okay, I have to put in the function in the graphing calculator. I have to think in terms of its domain very carefully. So there is no problem here. This is an exponential, it's defined everywhere. But there is a problem here. I have to make sure that what I pick is a number in such a way that the square root of this exists. Okay? I can pick 0 to start with. I can pick 1 or 2. No, 1 I can, 2 I cannot. Because 4 minus 8, I cannot take the square root from it. So I have to pick x values when I determine the 1-unit interval, so that 4 minus x cubed, we know that, we talked about it a lot, about the square root. I have to make sure that whatever I pick, so I can pick negative 10. Yeah, that works. Negative 10 cubed, it's with minus in front, is positive, so on and so forth. So I'm going to put this function in the graphing calculator. I'm going to share my screen, put in the graphing calculator, and punch in some numbers. So clear everything you have, and I get the square root, and I prefer parentheses here. It doesn't have to have. Some calculators don't need it, some do. So as you've noticed, I'm old-fashioned. I love my parentheses. Okay, minus e x squared. Okay, so I know that I have to go to the left with negative values, but I'm going to start. See, it already gives me a lot of error because the function is not defined. Okay, so I'm going to start with 0, see what happens. I'm going to continue with -1, and I'm super happy. Because at 0 is positive and -1 is negative, there must be a solution between -1 and 0. That's all I needed. So the interval that I pick is a -1, 0. Is a unit interval. The function is continuous there, and it changes sign. So by IVT, there must be a solution. There exists a c in the -1, 0, such that f of c is 0. And that's what we are looking for. In step number 4, after I do all this, since we are just talking about steps, so these are the steps, I have to create a function called Newton. I call it Newton. You can call it anything you want. It doesn't matter. And what will that function be? It will be exactly what you gave me a few minutes ago. It will be x minus f of x over f prime of x. Not x1, not x0, not x2, nothing. X minus f of x over f prime. So for this function is x minus, that's the derivative, and the function is this at the top. I will enter in the graphing calculator this function, not easy to enter, and I will start either at -1 or at 0. I have to be careful. If I start at 0, will there be a problem? This will be 0, not undefined, and this will be 0. I cannot start at 0. Starting at 0 will have the denominator 0, and that's not acceptable. So I can only start with x0 being -1. And then I will determine x1, x2, x3, whatever I need. Now, at this point, I look and see what they're asking me to determine. And they're saying, correct to 8 decimal places. So I will stop when I have a repeat of 8. Okay, so let's do that. Okay, I didn't mean to stop sharing, actually. Okay, so back to the calculator. Do not delete what you have in the calculator. This is very useful. Just insert x minus left parent, because this is the numerator. I don't want to put it in again. It's ugly as is. Okay, close the parenthesis and divide. Now I have to put in the derivative. Okay, left parenthesis. So I have messy. Be very careful. Let me stop sharing. Just make sure. I'm going to enter it like this. Definitely parentheses. Definitely parentheses. Definitely parentheses. And this can stay as is. But I need parentheses here, and then that. And then don't forget to close. Crucial. Otherwise, the calculator will not take this, what we want it to take. Okay? Okay. Left again. Left. One more, right? So -3 x squared. Close. Divided by, open, 2. The square root 4 minus x cubed. Okay. I don't like not having parentheses around that under the square root, but that's me. I also want parentheses. Most calculators, older calculators, pop up. The parentheses already pop up. You don't have to put them in. Okay, good. So I have enough parentheses, and then minus 2x and e to x squared. Don't forget the last parent in the denominator. Okay, so now I go to second and quit, and I go to variables. Right here, variables, and go to y, variables, function. Press enter for y1 because that's where my function is, and I will plug in -1 as discussed. When I press enter, this number, what does it represent again?